Welcome back. So in the last lesson, we discussed in general terms how a floating point number has several advantages over a fixed point number, and we learned some of the key terms, but you haven't yet learned how to find the value of a floating point number. So that's what we're going to do this lesson. So first of all, we're going to recap what you've already learned about fixed point numbers and about 2's complement. Then you'll learn how the mantissa and the exponent work together to define a floating point number. And you'll learn how to convert a floating point number into a familiar fixed point number. And finally, we'll look at what negative numbers look like when they're done using the floating point method. So let's just remember what we learned about 2's complement. We did that a couple of weeks ago. The most significant bit of any number is a negative value and all the rest are positive. So if a number begins with 1, that means it's a minus number. And fixed point, which we did earlier this week, in a fixed point number, the binary point is already in position. The column values are defined on either side of the binary point. And then when you've filled in all the column values, you can easily convert the number to and from decimal. But floating point is a different way of defining numbers with a fractional component. They're created from 2 numbers called the mantissa and the exponent. And because the point can move around into its best position, this lets you optimize the balance between range and precision according to whatever number you want to store. So that's all very well, but it's not much use if we can't find the decimal value of the floating point numbers. Otherwise, we just don't know what the numbers mean. So to do that, if we've got a floating point number and we need to find its value, we do 2 things. We convert the floating point to a fixed point number, and then we convert the fixed point number to decimal. We already know how to do that. If you don't remember how to do that, it's in the last lesson, the one before this, called 4.2. In this lesson, we're going to concentrate on that stage, converting floating point numbers to fixed point numbers. So in the exam, you might be given a floating point number. Remember, you'll be given 2 numbers, the mantissa and the exponent, and you'll have to convert it to a fixed point number. And then they might also ask you to convert that into a decimal. Or if they just say, oh, and turn that into a decimal, you have to do it through those 2 steps. Now, it might seem like quite a lot of work, but don't worry, if you do have to do a question that's a lot of work, there'll be a lot of marks for it. So, all right, let's get stuck in with floating point numbers. Floating point numbers are defined by a mantissa and an exponent. The mantissa is a fixed point number with a decimal point in it, and the exponent is always an integer, and they are both always stored using 2's complement. The conversion process is actually quite easy. You put the point into its starting position. I'll tell you about that in a minute, but you put the point into its starting position, you work out the value of the exponent, and then you hop the point that number. So if the exponent is 2, you hop the point 2. If the exponent is 4, you hop the point 4. And that's it. So get the mantissa, put your finger on the starting position or mark a little X, and then hop the point along, and that's it. You've got your fixed point number. Well, it's easier to explain by showing you an example. A mantissa is just as I say, it's a binary number, and it actually can be any length. They're not always 8 by any means. There can be 3, 8, 4, whatever number of bits. So it'll tell you in the question, or they'll just show you a mantissa. But the point always starts in the same place. one in from the left of the number. Here's another example. Here's another mantis. I haven't put the ones and noughts in yet. That's where the point ends up. One in from the start. One more. I expect you can anticipate where the point is going to go. Boink. There it is. So the point in any mantissa, big or little, the point is always one in from the left. The reason is that maximizes the amount of precision that you can have. So the exponent is an integer and it tells you how many hops. So a positive number hops the point to the right and a negative number hops the point to the left. Hopping the point is basically the same as binary shift, but it's just easier to do on the page than shifting all the bits along. You just hop the point along, and it's just hopping the point to the right is the same as shifting the bits to the left. However, you don't have to worry about that. If I'm starting to sound like gibberish and you don't know what I'm talking about, just remember, hop to the right, hop the point to the right, and that's it. So if the exponent starts with a 0, it's a positive number, hop to the right. And if it starts with a 1, it's a negative number and you hop to the left. I think that's quite easy to remember. Like if you're right about something, you're positive about it. So right and positive go together, left and negative go together. So that's how we do it. Hop to the right or left. So let's go through a few examples. You'll quickly get the hang of it. So let's say in the exam you were given a mantissa and an exponent, and in this example the mantissa is 5 bits and the exponent is 3 bits. I don't even bother to put the column values in the mantissa because we don't need them at the moment. The exponent I do need to work out its value. Remember, it's a 2's complement number, so the most significant bit is negative. So 0, 1, 0, well, that's 2, isn't it? So the exponent is 2. It's a positive number. And that means we're going to have to hop the point 2 to the right. So we put the point in its starting position, hop, hop, there it is. And that's our final number. And we can convert that into decimal. So it's a fixed point number. I've written the column values in now on either side of the point, and I expect you can see that the number is 2.5. Easy, huh? Let's do another one. In this example, we'll look at a negative exponent. If the exponent starts with a 1, it's a negative number, and that means we have to hop the point to the left. Now, the problem there is that there's a load of empty spaces to the left, so we're going to have to fill in the gaps, and we either fill them in with a load of 1s or a load of noughts. Let's have a look at an example. So here's a mantissa. It's a negative mantissa and a negative exponent. So the value of the exponent this time is -2. So we're going to have to hop the point 2 to the left. You can see how that's making the number smaller. So put the point in its starting position, and we've got to hop 2 to the left. So let me do that now. 1, 2. And the point is kind of in space. So let's fill in the numbers around the point, and we fill them in with 1s because the number started with a 1. We just fill up with 1s. And so the fixed point number is 1.1101. Remember, it's 2's complement, so the most significant bit is -1. So it's -1 plus a half plus a quarter plus a 16th, and that makes -0.1875 apparently. I did it on a calculator. Okay, so let's try another one. So here's another example where we've got a positive mantissa and a negative exponent. It doesn't make much difference to the overall process. So the value of the exponent is -3, -4 + 1. And that means we've got to hop the point 3 to the left. So there's the point, 1, 2, 3. Fill in the gaps with noughts because the number started with a naught. So we've got a funny number here with a lot of zeros after the point. It's a very small number, in other words. So let's turn that into a fixed point number. And the two values with a 1 under them are 0.625 and 0.03125. So there they are. Add them together and that's the answer. 0.09375, just less than a tenth. So that's 3 examples. I hope you've got the hang of it now. It really is as simple as that. Place the point, count the hops, and that's it. So here are 3 exercises for you to try yourself. Convert these 3 numbers. They're each defined by a mantissa and an exponent. In all 3 cases, follow the method that I've taught you to turn these into fixed point numbers and then find the decimal value of that number. Now, I'm going to give you a second or two now to pause the video or even close it down. Note down the 3 questions and work them out on paper. And before the end of this video, I'm going to show the answers. So if you want to stop the video now, and then the answers will come up in a minute or 2. So here are the answers. I've turned each mantissa exponent pair into a fixed point number, and then I've turned that fixed point number into a decimal number. So I hope you managed to do those. There's one last lesson of the week, and that will continue with the topic of floating point numbers. So see you in the next lesson.